Hey, welcome back to Engineers Workshop. It's July 1, very hot and humid here. Last week, my father-in-law was down for the week. We got a lot done. We tore into the Acroturn 1340 lathe. There were 3 or 4 gears in there that had broken teeth, and got this lathe from Doozer. So he had purchased replacement gears, and we had to tear down through the headstock and get the gears, the bad gears taken off. Took almost every shaft out of the headstock, but it's back together. So the other thing we did was we moved an inspection table out from under the overhead crane over near my electrical panels, and I was going to do a separate video with all of the inspection equipment, but I figure I'm going to pull this thing ahead. So one of the things I wanted to have very early on in my shop capabilities was real good measurement capabilities, and I wanted a nice size inspection table, and boy did I come across a good one. So this is a 48-inch square by 6-inch thick granite table, and it has a measurement system built into the center of it that I'm just going to have to show you, that involves some Gilman precision dovetail slides, hand scraped, and 360-degree rotation capability. It's just awesome. It came from a decommissioned rebuild shop out of New York. So let me just take you over to the video and show you some highlights on this thing and then how we leveled it up. This is a 6-inch by 48-inch square inspection table with this crazy measurement arm on it, mounted on a bearing. The whole column rotates, and it just takes absolutely nothing to rotate this. And if you look at these slides, let me get you a little closer. These are Russell Gilman precision slides, and these are hand scraped. And I went on their catalog, and the hand scraped slides are guaranteed accurate to a 0.5 thousandths per foot. So we've got an in and out travel, and we've got an up and down travel. And presumably, I guess you would mount your indicator or your measurement apparatus on this, and then you would be able to swing the slide, the arm, to and fro, and measure the heights of various features. And there's also another neat feature about this arm itself. The entire arm assembly is motorized. So besides it being really cool, I really don't have a clue what this was for originally. I mean, it's a neat measurement apparatus. And on the back side of this here, gotta make sure I don't hit my block. This side of the arm, this is 1.25 inches thick by about 8-inch steel plate that's canted out at an angle. And it has a lot of holes here to mount something. I don't know what this end does other than give another set of sharp corners to bang my head into, because I certainly have done that. It might just be a counterbalance for the measurement arm on this side. Actually have to move back here. But just look at it. Look at that scraping. And the screws, they're not Acme screws, those are ball screws. Now on the Gilman website, I can't even see for the particular models of the slides versions that have ball screws. But those things are zero backlash ball screw adjusters. The table itself is in beautiful condition. I mean, there is no nicks out of the corners. Unfortunately, there's no inspection stickers on this. I don't know what grade of a stone this is, but I'm willing to bet that with all this apparatus on it and the quality of the fabrication of the table, that I would hope it's an A-grade stone. Might even be a AA stone. I don't know, but it seems to be in extremely good condition. Now, if you'll notice, this thing comes through the table and it's eccentric to the table. That's because the only thing holding this stone down is gravity. And if you look at the way the base is constructed, it looks monolithic, but this is actually a weldment where it has round pipes, about 3-inch pipe. I don't know how thick it is, but inside this skin is a massive 2-inch by about 6-inch framing structure. Both top and bottom, it has cross members on the inside, and then this is skinned with about 12 or 10 gauge sheet, and all the welds are blended. And the nice thing about it is the leveling feet are at each corner, and they come straight up through to a leveling pad under the stone. So this thing has absolutely no flex to it. It's just a column all the way down to the floor. And you level the 4 points of contact of the stone up at the top. So I guess once you level the base, you can come around with an indicator on the arm, and right underneath, or rather on top of each leg, you can adjust the height of the granite using, like, let's say you get a 50 millionths indicator and you put a gauge block under there. You could adjust the height of the stone at all 4 points and get this thing perfectly flat. And then the only deflection would be literally in the floor itself, because, like I said, there's nothing in the base that would be in bending. Now, I mentioned that this thing was eccentric. Since gravity's holding it together, I had this thing on a flatbed trailer from New York to Virginia. And I had it strapped down as tight as I dared with 4-inch straps. But crossing a couple of bridges, the whole trailer made a couple of hops that obviously were bad enough to let the stone shift slightly. So what I'm going to do is I'm going to use the overhead hoist and put the straps under and just take a little bit of the weight off the stone itself, and then use a pipe clamp from the base to the far side of the stone and try to scooch it over a little bit and center up the column coming through the center. You can see where the original witness marks are from the 4 leveling pads. You can also see blocks attached to the stone, 3 points where there were, I guess, originally a 3-point mount on this stone, a tripod mount, and then it was converted to the 4-point mount, as you see here. Trying to get 50% of the weight, 50 to 75% of the weight of the slab taken up by the slings, so that I can use a bar clamp to recenter it. It's shifted in transport, so it's almost touching that center column. I need a better center. I need to pull the slab this way. I tried to do it without any lifting force on it, and it just seemed like it was taking a lot of force on the bar clamp. So hoping to make it a little lighter and get it to move easier. I must have hit a sweet spot because it's moving. Zoom you in here. It's certainly not perfect, but it's better. I think it's good enough for me to begin to try to level the stone relative to the base. One thing I'm going to check to see if it maybe actually did one of these numbers, actually just twisted on the base. I changed my strategy a little bit. I want to go for a kind of a gross leveling with the long stem indicator, long travel indicator, and just to see how this thing fared in its journey, how far out it is relative to the exact axis of this pivoting arm arrangement. And so if I go out here and I lean on the end of this with, I don't know, maybe 10-15 pounds, I can get 3/1000ths of deflection. So you do have to be careful with how you use this. But we're going to start with this corner as a 0, and I'm going to sweep it around, and we'll record what the relative reading is. If the number goes higher, that means it's getting closer, and if the needle goes this way, that means the stone is getting farther away. And we're going to just walk this around and watch that needle. Oh my God, look at that. On the far side here, I'd say we're -1. It's -1/1000ths. Walking around, walking around. +1.5. +1, just a hair over. Let's see how we repeat. And we're back at 0. Well, I am absolutely impressed that this thing has stayed within a thousandth and a half over diagonally opposite here, probably, well, 48 inches. I'm sweeping, within an 1/8 inch of the stone, so unreal. So I can make some very, very tiny adjustments on this and bring this back to dead nut 0. Then we'll run the crank in and we'll see how the stone, it should stay perfectly flat on the in and out once we get the 4 corners tracking correctly. So this thing has leveling feet at the 4 corners that's basically a 3/4 inch fine thread stud with a hex on it. And then it has a little 1/2 inch projection on the bottom of the foot. And this was digging into the concrete. So, you could just take and put a washer on there, a nice big flat washer, which I initially considered doing, but that wouldn't take care of any undulations in the floor. So what I decided to do was to put a spherical washer on this. And the spherical washer has a cut in it that looks like that. Section that. And then it has a mate. And so the spherical can swivel in that relative to this lower surface. Then I put the big flat washer, I just machined a shallow pocket where this spherical washer can sit, and then the original hole in the washer's down here. This worked out really well, so I'll include that in the video and then show you some of the capabilities of the measurement arm, and if any of you have any ideas of what this may have originally been for, or a manufacturer of this thing, man, put it in the comments, because I have no clue. There's no markings on the table, but it is just super cool and in very, very good condition. So back to the action over here. The adjustable legs of this granite slab have a little stub sticking down below the hex, and I could just drop these on top of a washer, let that stub project into this hole, because the stubs are tearing up the concrete. But that wouldn't, account for when the floor has got, little local spots out of level. So I decided to use a spherical washer. And so the spherical washer will actually let those two surfaces go non-parallel. And all I'm going to do is machine a little pocket in this washer, maybe 70 thousandths deep, to have that lower half sit into. And we'll measure the OD of this and just make the pocket about maybe 5 thousandths bigger. It'll come down till I touch, and then I'm going to go an additional 70 thousandths. 10, 20, 30, 40, 50, 60, 70. Yes. I'll do the next one the other way. You know what I could do? I could draw a circle on the wood, and that way I can just position the other ones, assuming that they are similarly sized. They're just punched. I'm going to put anti-seize on every surface. That way whatever wants to slide can slide. Okay, try letting it down. Pretty good. Yeah, it's sitting different because this one doesn't have any weight on it at all.
Doesn't have what?
No weight on it at all.
Yeah, I figured that seemed to get.
So we'll re-level it.
Where's your precision level at?
Probably put away. And I can tell it adjusts easy. Better than digging into the floor. All right, we just went through with the precision level, the Lufkin number 59, half thousandths per foot. And we got it basically dead nuts in both directions. It's my father-in-law, Steve Roberto. How long you been a machinist?
Too long.
It was like at least 30 years, right?
Oh yeah, at least, yeah. 68, I think.
And when'd you retire?
When I was 62. I don't.
Yeah, you've been retired about
It's over 40 years.
40 years, yeah. Steve's worked on some really big machines. So you had the Glunt was the 60 horsepower planer mill. He rides the in the head, and then the Taylor Winfield was the big one.
No.
No?
United Engineering, yeah.
And you said it was like about 200, 250 horsepower?
Yeah, they had two heads.
And what size was the spindle on that?
What was it, 13 or 14 inch? And it had 200 some inches between the housings, you know, you could fit through it.
Right.
We milled all them.
And how much,
welding housings.
what was how far could the quill extend?
Oh, it was.
I mean, how far could the spindle extend out? Like to do?
No, it was.
Oh, that was a vertical spindle machine.
Yeah.
Oh, okay.
Planer mill, and then it had two side jacks too. They
Gotcha.
could come out. They could
Okay.
come out.
Okay.
Oh, they went out pretty far too.
Yeah.
You get them out too far though, they would, you know, rattle back.
Yeah. Big stuff. Bigger than anything that.
In the housing, you were 295 tons, you know.
Yeah. I don't think that there's anything being shown on YouTube that's anywhere close. Even there's some of the guys that got some really biggest machine they got 37,000 pounds, 40,000 pounds. I mean, yours literally the buildings were built around them, I'm sure, right?
Oh, that was big, yeah.
Yeah.
It went to Korea though. They bought it, the Koreans bought it.
Okay, yeah.
Yep.
Man. So this is, you call this a layout table?
That's what it looks like to me, yeah.
We can't figure out what all this arm, like how it may have been set up, but I've just been putting indicators on the vertical slide here, and then you can put parts under it, check, you know, within a couple tenths. This table sweeps within a tenth on a 48-inch circle, supported by the 4 points.
Solid too.
Yeah, and we got it on good leveling feet now, so it's a heck of a little inspection station. I got to figure out some way to cover it, make a felt-lined piece of plywood, at least put over top of the granite. Put my drawings over here just because it's convenient. And then of course the back side of this, watch your head.
Yeah.
We got the motorized up and down. Where's the plug?
Remember, they don't have a brake.
Yeah. Leave it about there. It's a good height for my indicators. And one of the things I got to do is get the cross travel fixed up. Even though I sweep within a tenth on one given radius, if I run it in, I'm 20 thousandths out. The transporting jostled this thing and tweaked it downward, which, you know, we can adjust out, loosening that and keep bumping it until it's dead on the money. What's that, about 24 inches of travel going that way. All right, that's enough work for today. It's hot. Now that I have the top surface precision leveled, and really I've got it within about a 0.5 thousandths per foot, which is awesome. I'm going after basically the level of the surface relative to the pivoting axis of this arm. This arm pivots on some really precision bearings, and I want to show you how closely this thing travels to. This is a tense indicator, so I've got it zeroed on top of one table, and I'm going to just travel around here, and this indicator is in contact. You can see we're down maybe a tenth at that edge. Back to zero at the next 90-degree corner. Essentially back to zero. Minus a tenth. And back to zero where we started. Just adding the weight of the camera stand, which isn't much, changed this thing about 4/10. If I just take my finger and I lift up on this with a couple ounces, you can see I'm changing it by 2/10. Well, I hope you enjoyed that. That table is going to be a central part of, you know, my inspection department. Ability to take sizable pieces on there and check heights, check steps. Also, I hope you enjoyed talking with my father-in-law. He has just, you know, 40 years experience as a machinist working on huge steel mill components at a number of different places. I remember seeing being at Glunt Machine, and he wanted to show me this drive shaft that they were working on. And it was one of those deals where, you know, I'm thinking, well, okay, it's big. Where is it? Well, this thing was like 48 inches in diameter. The thing was behind me the whole time, running, you know, 60 feet long, and I didn't know what it was because it was so huge. And it had just these massive yokes at the end of it. And they would put these things up on the lathe, build up weld material on them, an inch thick, turn it off. I mean, it just, and that was the small shop. You know, Glunt did the smaller work. The big stuff, you heard him say, was done at United, where he worked on a 250 horsepower planer mill. He says the spindle was 13 inches. He thought it might have been 18 inches. I mean, 18-inch spindle. That gives you an idea of the size of these things. So, hope you enjoyed it. I'll show you the rest of the inspection equipment in another video, but tune in next time for Engineers Workshop. Until then, stay safe. Thank you.